Hi guys, in this video we will discuss about cloud concepts. So let's start. Please go through the disclaimer. I'm pausing for 5 to 10 seconds. Okay, let's start. Let me take you through the introduction of cloud concepts. So here we are talking about cloud computing, and cloud computing is similar to using the resources on rent from a public cloud service provider. And cloud provider can provide us storage space, CPU cycles, and other development environments on their cloud. Let's go ahead. And while using the public cloud service provider, we use their resources and pay for what we use. And some of the example of cloud providers are Google, Microsoft, and Amazon. Azure is the platform provided by Microsoft, and that is a cloud platform. And for Google, GCS is the platform, and Amazon has AWS. And let's talk about who is responsible for managing the physical hardware. In public cloud service, the responsibility of managing the physical hardware lies with the cloud service provider. And what all computing services are offered by cloud service provider? They provide the infrastructure, like they provide us the ability to create VMs and provide us development platforms, or they can provide us software as a service. For example, Office 365 is the SaaS service provided by Microsoft. And what all computing services the cloud service provider provides? They provide us computing power, they provide us storage, they provide us networking, and they also provide us the analytics or business intelligence services as well. Now let's talk about compute power. So under compute power, as a consumer, we are dependent upon the computing services provided by various cloud providers that make up the internet. Now here we are talking about general internet, where we use services of various kinds like email, or maybe we are booking for a hotel or paying some bill. So those are the services provided by companies, and basically they are cloud providers. They are providing certain kind of services, and we are using those services over the internet. And we have just discussed about the example of services. So example of services can include email, purchasing some item online, or paying bills online. And one of the other ways to work in the cloud is we should be able to create virtual machines in cloud of one of the services provider. For example, we can create our own virtual machines in the Azure cloud, and basically the cloud provider runs our virtual machine on their physical server in one of their data centers. And let's talk about what the virtual machine is. So basically virtual machine is an emulation of a computer that runs the guest operating system, any operating system like Windows 10 or Windows 8 server or 2012 server. It basically emulates the computer environment, and we can also install whatever software we need on this VM. And apart from using this VM, we can also use any other options like containers and serverless computing in the cloud. We will discuss about concepts like containers and serverless computing in our next slides. So let's move ahead, and now let's talk about what the containers are. Basically, containers does not use any operating system. We can directly put our applications on top of containers, and containers provide the runtime environment which can directly run our application. So there is no need for operating system with the use of containers. So containers provide a consistent isolated execution environment for applications. with no operating system required. And these are basically similar to virtual machines, except they don't require a guest operating system. Again, we already talked that no operating system is necessary. They just provide the runtime environment in which our applications can run. And applications can and all of its dependencies are packaged inside the container. And standard runtime environment is used to execute the application from the container. And as our container does not use the guest operating system, therefore it starts up in just a few seconds, as there is no operating system to boot and initialize. So execution is faster with containers because containers can boot up faster, as they does not require any guest operating system. And Docker is one of the platforms where we can create and manage containers. And multiple containers, we can run multiple containers on a single machine, and these containers can be moved to different machines as well. And this basically allows applications to be deployed in multiple environment, on-premise or cloud. So there is no environment dependencies, and each machine can host multiple containers, and these containers can easily be moved to different machines or different environments. Now let's talk about what the serverless computing is. And basically serverless computing lets us run an application without the need of creating, configuring or maintaining a server. So in this system, a virtual machine is not required at all. Neither do we need a container to host an application. So this is basically known as serverless computing. So let's go ahead. And basically in this environment, in order for application to run, we broke down the application into a number of different functions, then can be triggered by some actions. And for serverless model, we only require to pay for the processing time used by the function as it executes. Whereas on the other hand, if we use the VMs and containers, they are charged while they are running, even though the applications that are sitting idle on them. So basically, even if we are not using applications on VM and containers, still we will be charged for using those VMs and containers. On the other hand, if we use serverless computing, we can just pay for the functions whenever they execute. We just pay for the processing time. Now let me show you the diagram contrasting the virtual machines, containers and the serverless architecture. So if we take a look at this section, the leftmost section, here we have our physical hardware or physical machine. On top of that we have host operating system. On top of that we have hypervisor controller, sorry. And on top of that we can create several virtual machines. This is virtual machine 1, virtual machine 2, and each virtual machine have its own hardware or virtual hardware. On top of that virtual hardware we need to install operating system, and on top of that operating system our apps can be running or can be installed. This is the diagram for virtual machines. Whereas if we use the containers, we have physical hardware. On top of that we are running operating system or host operating system. On top of that, instead of hypervisor controller, we are running container engine, and this container engine let us create the containers. Here we have container 1, container 2, container 3, and in these containers operating system is not required, or the guest operating system part is not required, and our applications and its dependencies can be packaged inside the container. And container engine environment provides the runtime, standard runtime through which these applications can run. And the last diagram is for the serverless model, where we have physical hardware, we have host operating system on top of that, and we have serverless runtime environment. And our application is broken down into a number of functions, and we need to pay for only for a function during its execution time. So whenever the function is invoked, we only have to pay for that particular function for its execution time. This is a best cost saving mechanism if our application can be broken down into several functions. So let's go ahead. So let's talk about the storage part. So cloud-based storage can be scaled to meet your needs. So the public cloud service provider can provide us unlimited storage depending upon whatever needs are, and it can be scaled. In some cases, storage is expand and contracts automatically. So cloud provider can also provide us facility where our storage can expand automatically and contracts automatically as well, depending upon our load or as per our requirement. And we have to pay for exactly what amount of storage is used at any particular point in time. Now let's talk about the benefits of cloud computing. Cloud computing is cost effective, and as it uses the pay-as-you-go model or consumption-based model pricing, where we only have to pay while we are using resources. If we are not using resources, we don't have to pay anything, and this saves us our upfront infrastructure cost. We don't have to buy servers in order to run our application on host operating system. We don't have to put investment in a data center, etc. And we don't need to pay for the infrastructure that we do not use to its fullest, and we don't need to pay for any resources which we are not using, and we need to only pay for additional resources as and when required, and we can stop paying for resources that are no longer needed. And cloud computing provides us the scalable platform, and where resources can be increased or decreased as per the demand or workload. And there are basically two types of scaling. One is scaling upwards, or the other is scaling out. The scaling upward is also known as vertical scaling, and this can be done to increase the power of existing server, like adding more CPUs or RAMs to the server. In this case, VPUs, we can say, virtual processing units. And in the horizontal scaling, we can add more servers that can work as a group to share the workload. And sharing can be, or scaling can be done either manually or automatically as per the request for resources. Now let's talk about some of the other benefits of cloud computing. It provides elasticity, in the sense that if the demand for resources increase or decrease, cloud computing system adapts accordingly by adding or removing resources, and it keeps our operating system current with current patches, and basically in turn it eliminates the burden on top of us for maintaining the software patching on the operating system, hardware upgrades, and the other IT management tasks. All these tasks like software patching and hardware upgrades are managed by cloud service provider. And if there's any component failure, like if some disk fails, that disk will be replaced by the cloud service provider. Basically, we don't need to, as a user, we don't need to take care of any hardware management task. And cloud computing is more reliable, and basically it ensures reliability by offering the data backup services and disaster recovery services and data replication services to make sure that our data is always safe. And it also provides fault tolerance in case any component fails, or if there is any disaster recovery situation, by allocating the similar component or routing traffic to any other mirror server. Let's talk about some more benefits of cloud computing. Basically, cloud providers have their presence globally in various regions across the globe, and basically they can allocate servers that are closest to the users to have a faster response times. And they also provide a redundancy by replicating services and data to other region. This can provide data security in times of disaster recovery to the user. User can replicate its data to another region as well. Another benefit of cloud computing is it provides a more secure environment, as cloud providers invest heavily in walls, cameras, gate security personnel, etc. to protect their physical assets. Thereby they secure physical access to the servers by the unauthorized personnel. Now let's talk about CapEx and OpEx. CapEx refers to capital expenditure and or capital expenses, and OpEx refers to operational expenses or operational expenditure. And basically what do we mean by capital expenditure? And it basically refers to spending of money on physical infrastructure upfront. For example, if we are hosting our own data center or creating our own data center, we need to provide all the money upfront to buy those equipments and all the networking, cabling, etc. racks required for data center. We need to provide the infrastructure. We need to provide capital for physical infrastructure upfront, and the cost of this expenditure can be deducted over a period of time from the tax bill in the form of depreciation. Whereas if we contrast it with the operational expenditure, it means that by operational expenditure it means that we are spending money on production services, and this expenditure can be deducted in a single go from the yearly tax bill. This is by operational expenditure means we are using the services of a cloud service provider. In this case, we don't have to put any money upfront for buying any physical hardware or data center. We are just paying for the services or infrastructure provided by the cloud service provider, and basically we can take advantage of these costs as they can be deducted in a single go from a yearly tax bill. Now let's talk about on-premise data center cost, or CapEx we can say, where we have our own data center. So this on-premise data center cost or the CapEx cost includes server costs, because we need to buy the servers. And basically if we are spending money on buying servers for our own data center, this can affect our cash flow, and as we have to pay for these servers upfront. And basically server cost includes cost of hardware components and cost of supporting these hardware components. So first cost is cost on the servers, and second cost is cost for having personnel to look after these servers or hardware components. And there are also additional costs involved in acquiring the additional servers for fault tolerance and redundancy, which are used in the case of server clustering. And redundant power supplies and uninterrupted power supply is also required, so that also adds to cost. Now let's talk about storage cost. If we are managing our own data centers or servers, there are storage costs involved as well. So basically storage costs refer to the cost of storage hardware components and cost of supporting this storage. And centralized storage can be expensive, and fault tolerant storage can even be more expensive if we have to buy these storage items. And there are also costs involved in having network, so network costs are involved. So these basically include cost incurred on cabling, switches, access points and routers, and it also includes cost of wide area networks and the internet connections. And there's also cost involved in maintaining the backup and backup infrastructure. So there are backup and archive costs as well. So we need to maintain backup hardware as well, so that involves cost. And there is additional cost for backup maintenance and consumables like tape drives, and there are disaster recovery costs as well. So this basically involves cost involved in creating a disaster recovery site, cost of having additional servers in the disaster recovery site, and other associated costs. And we also have to provide for data center and infrastructure cost. We are having our own data center, so this include cost for designing and implementing the data center, which include cost of racks, cooling equipments, cooling, air conditioning, uninterrupted power supply, cabling, electricity, floor space, building maintenance. These are all example of data center infrastructure costs. And there is also cost involving having technical personnel to maintain the data centers and the equipments. So these costs have to be taken into consideration if we are planning for our own cloud infrastructure or on-premise cloud infrastructure. And there's also cost involved in keeping the technical personnel for installation, deployment and management of the system in a data center and disaster recovery site. Now, so far we have talked about the capital expenditure and various costs involved in that, having an on-premise data center and whatever cost can incur in maintaining our own on-premise data center. Now let's talk about what all costs are involved in cloud computing, or if we are using the services of public cloud provider. So let's see. So there are some costs involved, like software costs for software and other components. So basically, cloud service provider or public cloud service providers provide us the pay as per use or pay per use cost model. So basically, this model requires actively managing our subscription to ensure that users do not misuse the service and only use provision accounts are being used in order to access service application. So let's not go into that much detail. Basically, public cloud service provider provide us the pay as per use model. So whatever resources we are using in the public cloud, we only need to pay for that. And basically, if we are using public cloud service provider, our billing starts as soon as the resource is provisioned or some machine is provisioned to us by the provider. And in this model, it's user responsibility to deprovision the resources if they are not getting used in order to minimize the cost. Otherwise, billing will be constant even if the resources are running idle. For example, if a virtual machine is provisioned to us by the cloud provider, and even if we are not using that virtual machine and we keep that machine in on state, this will keep on attracting the billing amount to us. And if we don't want to use that particular virtual machine, we have to deprovision or turn off the machine ourselves. Otherwise, billing will keep on occurring to us for the resource, even though we are not using it, or even if they are running idle. So it's our responsibility to deprovision the resources if we are not using it in order to cut the costs. involved. And there are scaling costs as well. If we are using public cloud service provider, scaling cost in terms of if we need additional resources, that will attract costs. So basically scaling costs are the cost based on usage demand instead of fixed hardware and resource allocation. So hardware resources can be scaled like CPU, RAM, any additional servers, etc. And billing can be done as per the number of users or CPU usage time or allocated RAM, IOPS or the storage space used. Various factors can be considered for billing by the cloud service provider. And let's talk about the cloud deployment models. So we have public cloud, private cloud and the hybrid cloud. These are the three cloud deployment models. So first let's talk about the public cloud. So which is the common deployment method where we use the services of public cloud service provider. And in this mechanism we don't need to manage any local hardware in our own data center, and everything runs on the cloud providers hardware or cloud providers infrastructure. And some of the example of public cloud providers are Azure, AWS and GCP. It's not GCS, or maybe you can say GCS as well, Google Cloud Services. Basically they provide GCP platform. And some of the advantages of using public cloud is they are highly scalable and agile in nature. By scalable we means resources can be scaled up automatically or can be increased automatically by the cloud service provider depending upon the load. And in this model we only pay for what we use, and there's no maintenance responsibility lies with the user if we use public cloud service provider. And one of the example of using public cloud services, if we want to deploy our web application or blog site on cloud providers hardware resources. In this case, users do not need to worry about maintaining the hardware and can instead focus on maintaining the site. So this is the example of using the public cloud service. And some of the disadvantages are if we have any specific security requirements that require us to keep the data of the customer in our own infrastructure, and customer don't want us to put that data on a public cloud, or maybe there are some government policies or legal requirements to keep the data within our own data center, then facilities of public cloud provider cannot be leveraged in those cases. And there may be legacy applications like some of the applications running on mainframe that cannot be run in a public cloud. So yeah, again, using public cloud has some disadvantages under certain circumstances. Second type of cloud is the private cloud, where we are managing our own infrastructure for cloud. So ideally we can use VMware to create our own cloud infrastructure. That can be a private cloud infrastructure. So let's see what's under that. So if we are managing a cloud in our own data center, that is referred to as the private cloud, and basically it provides a simulation of public cloud to the users. And if we are managing our own cloud, we should be responsible for management of cloud hardware, maintenance and installation, etc. And private cloud can be used in a situation where organization has data that cannot be put on a public cloud. So this is the condition where we need to use the public cloud. This is the condition where we have to use the private cloud instead of public cloud. Some of the advantages of using the private cloud is that if we have any legacy applications that require specific type of hardware like mainframes, we can use that mainframe within our private cloud, whereas the same mainframe cannot be provided by the cloud service provider, public cloud service provider we can say. So we can run legacy applications. And secondly, we will have more control over security, because if we are using the private cloud infrastructure, the security will be managed by us, and we have more granular control on the security rather than security services provided by public cloud service provider. If we are using public cloud service provider, security is provided by them, and we do not have control over that security. And the private cloud meets the strict security compliance and legal requirements as required by the organizations. And some of the disadvantage of using the public cloud or some of the disadvantage of using the private cloud is we need to provide initial capital expenditure for that, and investment has to be made in buying equipment for the private cloud. And it also limits the agility as fresh investment is required for buying new equipment, etc. And it also requires the expert IT skill or expertise to manage the private cloud infrastructure, so those involve cost as well. And we can also leverage the third type of cloud is hybrid cloud. We can leverage this mechanism as well. Here both the clouds, both the public cloud and the private cloud, both are used. So it's basically a combination of public and private cloud, and it is helpful in the situation where we cannot put certain data on the public clouds for any legal reasons. And some of the advantages are it accommodate applications or legacy applications, we can say, that can only run on the old hardware or old operating system that is in private cloud. In those situations we can use hybrid cloud, and with hybrid cloud we can take benefits for both the public and private clouds. Some of the disadvantages are maintaining both the public and private cloud is more expensive than selecting one particular deployment model, and basically it is more complicated to set up and manage. And now let's talk about the types of cloud services. The first type of cloud service, or the services provided by the public cloud service providers, are first service they provide is infrastructure as a service, or we can say IaaS. Let's see what it is. And basically this is the most flexible category of cloud service, and in this type of service user is responsible for the purchase, installation, configuration and management of their own software, operating system and applications. So by this we means basically the public cloud service provider gives us the infrastructure where we can create our own virtual machines and configure them, install operating system on top of them, and install any application on top of that operating system. So this is the most flexible category of cloud service, and it also ensures that basically in this type of mechanism, in order to ensure that service is up and running, it is a shared responsibility of both the cloud service provider and the user or the customer. And basically cloud provider needs to ensure that the cloud infrastructure is available, and customer needs to ensure that service is configured correctly and is available to their customers. And in this type of mechanism, we don't have to buy, or users don't have to buy any hardware. We can rent it. So yeah, virtual machines can be used in the public cloud service provider infrastructure. And advantage of this model is this model can be used to migrate existing applications from on-premise to cloud. And second, it can be used for quickly setting up and dismantle test and development environments. For example, we can set up our test environments by creating virtual machines as per our requirements, and it makes scaling development and testing environments fast and economical. And it can also save us the capital expenditure cost involved in storage management, and also in the skilled staff that is used to require that storage management system. And this service can be leveraged to keep unpredictable demand and steadily going storage needs. The second type of service provided by the public cloud service provider is platform as a service, or PaaS we can say. And in this type of mechanism, they provide us the environment, or cloud service provider provides this the environment to build, test and deploy our software applications. In this type of mechanism, they don't provide us operating system to manage, or they don't give us the option to create any virtual machines, but they provide standard environment where we can use their service. So for example, Azure SQL database is one of the PaaS service provided by Microsoft, where we can use their SQL server. And basically PaaS refers to they provide us environment for just building and testing the applications and deploying the applications with no control over operating system or virtual machine. So let's discuss about platform as a service. So we already discussed that it provides us the environment for building and testing the applications, and in this type of mechanism, user is responsible for developing their own application, but however the user is not responsible for managing the server or infrastructure or operating system we can say. And it basically helps us in creating the application quickly, because we don't have to manage the underlying hardware or the operating system. Example of this service is the deployment of web application using PaaS without the need to install and manage operating system, web server or even system updates. So in this case, the cloud service provider or public cloud service provider provides us the infrastructure where we can directly host our application and do not need to take care of the operating system, web server or even any of the system updates. And it also provides us the development framework and which developers can use to build applications, and it lets developer create applications using built-in software components. And under this mechanism, analytics services and business intelligence services are also, or tools are also provided to allow organizations to analyze their data, find insights and patterns to predict outcomes that will help in making improved business decisions. The third type of mechanism is software as a service, and it basically refers to software that is centrally hosted and managed for the end customer. And in this mechanism, user just use the application software that is managed by the cloud service provider, and they are not responsible for any kind of management maintenance of that software. And it is basically a subscription based service Example is Office 365, for which we can take subscription. And here is the diagrammatic contrast for each type of service mechanism. If we look at the on-premise infrastructure, we need to take care of everything, starting from networking, storage, server, virtualization, OS, middleware, runtime, data, and applications. However, if we use the public cloud service provider infrastructure as a service, it will abstract us from taking care of certain components. For example, in this mechanism, the service provider manages the networking, storage, servers, and virtualization, where user need to take care of OS, middleware, runtime, and the data and applications. So this light blue part is the part which user has to take care of, whereas the dark blue part which provider provides us or take care of that particular part. So cloud service provider takes care of networking, storage, servers, and up till virtualization under infrastructure as a service. Under platform as a service, the cloud service provider takes care of some additional component. It takes care of OS, middleware, and runtime, etc. And user need to take care of application and data. And in the case of software as a service, everything is managed by cloud service provider, and user does not need to take care of anything, and they just have to subscribe to the service. So I thank you guys for watching this lengthy video. Guys, please do share this video if you really like it, and subscribe to my channel. I thank you once again for all your time. Have a great day.